Math 082, Practice Final Review, Problems 80, 81, and 82. Here on problem 80, I'm going to treat this problem a little bit differently, because a squared plus 2ab plus b squared is a formula. And what I'm going to do is give the factorization and then prove it's the right thing. This is not a typical test problem. As it turns out, it factors as a plus b times a plus b can be written as a plus b squared. Let me show you that this is the right factorization of this polynomial. Let's FOIL. A times a is a to the second power, or a squared. On the outside of FOIL, a times b is positive ab. On the inside of FOIL, we have b times a. We could write that as ba, or we could write by the commutative property of multiplication, a times b. Finally, the last, b times b, b squared. Here we have 1ab plus 1ab. Those like terms add to give us plus 2ab. So we have a squared plus 2ab plus b squared. And that matches our original expression. So a squared plus 2ab plus b squared factors as we have just verified, a plus b times a plus b, which is equal to a plus b squared. A bit of a non-traditional way of going about this problem, again because it's a formula, not a typical test problem. Let's check the answer key. We must factor completely here in problem 81. First, we ask ourselves, is there a GCF? And there is. 2, negative 6, and 4 are all divisible by 2, so the GCF consists of 2. We also consider the powers of x cubed, x squared, and x to the first power. You take the least among those for your GCF, which is x. So we have 2x. It would take 2x times x squared to give us 2x cubed. It would take 2x times negative 3x, because 2 times negative 3 is negative 6, and x times x is x squared, to distribute to give us the middle term. And it would take 2x times positive 2, so we write plus 2, to give us this term, 4x. We will temporarily ignore the GCF 2x and just focus on factoring x squared minus 3x plus 2. And because for this quadratic a is equal to 1, we can use what I call the a equals 1 shortcut, which means I need to find two numbers that multiply to c, which is 2. The same pair of integers must add up to the value of b, which is negative 3. Those numbers are negative 1 and negative 2. Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3. So the a equals 1 shortcut factoring gives us x minus 1 times x minus 2. 2x cubed minus 6x squared plus 4x factors as GCF 2x times x minus 1 times x minus 2. Let's check the answer key. Note that these parentheses on 2x are unnecessary. Here in problem 82, we will factor this by the AC method, in spite of the fact that there are two variables. Again, because a, the leading coefficient, is equal to 1, we will use the a equals 1 shortcut. So we need to find two numbers that multiply to c, which is negative 4. The same pair of integers must add up to b, which is negative 3. The pair of integers that satisfies both conditions are negative 4 and 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So here's what we do. The AC method, we bring down x squared, but negative 3xy will be split into two terms. Both of them xy terms, but with coefficients from our a equals 1 shortcut diagram. We have minus 4xy plus 1 xy, and then we bring down the last term, negative 4y squared. Now we are going to factor by grouping. We group the first two terms together. Their common factor is x. We have x times a quantity, x minus 4y. Let's double check. X times x is x squared. X times negative 4y is negative 4xy. Now we'll group the second two terms together. A little shortcut or hint to remember is, because we were able to fill out this diagram, this factor here will automatically be repeated. So I will write it down. And then it's just a question of what do I distribute to both of these to make these two terms here. And the answer is a positive y, so I write plus y. Y times x is xy. Y times negative 4y is negative 4y squared. So the factorization of our polynomial here is x minus 4y, that's this factor, times x plus y. Let me rewrite that so you can see it better. Now I invite you to check this by foiling to see that you come up with this original polynomial here. I'll let you do that. We'll check the answer key.